Next speaker is Dr. Sasha Ushenko from Leiden. His talk is about quantum technologies at Leiden. Please.
Hello, my name is Sasha Ushenko, or Alexander Ushenko. I'm CTO at Leiden Cryogenics. I'm going to talk about our systems. I'll start first with a brief introduction of the company. It was started in 1992 by Professor Frossati. So since 70s, Giorgio was doing research very low temperatures, and he was also advancing the technology of the dilution refrigerator. In 1976 in Grenoble, he made a dilution refrigerator with plastic heat exchange, 5.5 millikelvin temperature, base temperature. 2 years later, he developed silver heat exchangers, reached the base temperature of 2 millikelvin. And these silver heat exchangers is the technologies that being used in every dilution fridge you have in your lab today. Basically, whatever company you buy, your provider will have the reverse interchangers that Giorgio developed. In 1980, he moved to Leiden, where he developed the Cryo One, the dilution refrigerator, which hold the record for the lowest base temperature for more than 15 years. And on this fridge, he did some awesome experiments. For instance, he actually, well, his team filmed the growth of helium-3 crystal, which requires extremely low temperature, extremely high pressure, so very extreme conditions. You also need to film it. So that's an amazing achievement. Later, he, with a group of 4 or 5 people, he developed the gravitational wave antenna in Leiden, which is a sphere of 76 centimeters of 1.4 tons of weight, which was cooled to 50 millikelvin and reached the sensitivity of 10 to minus 20 meters. And so obviously he was good in what he was doing. And in 1992, he started a company to make the dilution fridges as a commercial product. At that point, of course, all the fridges were wet fridges. Everything, you needed liquid helium to cool the fridge, you needed to refill liquid helium, it's a pain to run. Liquid helium is also expensive. So in 2004, Leiden Cryogenics delivered the first commercial, what is called now dry dilution refrigerator, which is also a basis for all the fridges you use in the lab. It's not the first dry fridge in existence, but is, as far as I know, is the first commercial fridge that was delivered with this technology. So our company is quite small. It's 25 employees, 6 physicists and 15 technicians. We are very lucky because we are very close to the Leiden Instrument Maker School, which is a school started by commonly known as over 100 years ago with the aim of training cryogenic technicians. So we have most of our technicians come from there. We regularly have interns come and do an internship in our company, and some of them stay after they graduated. So we are very, very lucky in this regard. We have our own workshop with 2 CNC machines, a number of million machines and lathes. So we do almost probably 90% of production we do in-house. Build our own fridges, basically. Only the biggest parts that don't fit in our machines we outsource. Okay, this is how our fridge looks like. Pretty, classic design. You have a frame where the cryostat is resting on. The frame is called the lifting table. I'll talk about it later. It's a pretty unique feature. There is a gas handling system which takes care of circulating helium, pumping the system out, these kind of things. Of course, it's cooled by the pulse tubes, as all the fridges now. So we have a stack where the pulse tube compressors are mounted. The cans are also stacked because of the lifting table. There is a very unique and easy way of opening and closing the fridge, which also distinguishes it from all other systems. And we have electronics trolley for all your temperature measurement and control, magnet power supplies, whatever you need. The system needs about 2 by 4 meter of floor space and about 3.5 meter of ceiling height. In practice, most people actually move the Cryomac compressor, the pulse tube compressors away because they're very loud and also generate a lot of electromagnetic. So most further away, but it can be pretty compact. So I'll go quickly through the features of our system, then later I will go in more detail about it. So the sample space is about 50 by 50 centimeters. The mixing chamber plate diameter is 49, but there's a little bit more space with the next shield. We have these wiring inserts, which are very easy to pre-assemble on the table and put it into the fridge, which is what most quantum computing people are interested in. We have top-loading probes for fast sample exchange. And magnets, of course, is a standard option. We have single solenoid vector magnets. Our fridges are heavy, and that's on purpose. So they're heavy to have very low vibrations, and we work a lot with companies like AutoCube to build AFM or confocal microscopy at millikelvin temperatures, and apparently our fridges are the best in this regard, in regard to the vibration levels. They're heavy, but it doesn't mean that they take a long time to cool down. So we use liquid nitrogen pre-cooling circuit where you can circulate liquid nitrogen through the dilution refrigerator. And in principle, with systems with 2 pulse tubes, you can cool to 4 Kelvin in about 15 hours. And the systems with 1 pulse tube, it takes around 24 hours. To warm up, we have an integrated power heaters as a standard option. So even with a very big and heavy magnet, most of the time you can warm up overnight. If you want, fast turnaround time, it's very helpful. The lifting table provides very easy operation, like one person can open and close the fridge, and I'll show you further how it works. And the last but not the least, you can also choose the color of the system. So in this case, for instance, the gas handling is blue and the cans of the cryostat would be blue, but we sold quite a few systems that were pink, white, or whatever, matching the branding of the company that wants to buy them. People like that. So our standard model range is just 3 systems, basically, which differ by the base temperature and the cooling power. So the smallest cooling power is 500 microwatt at 100 millikelvin, the base temperature just under 10 millikelvin. And the highest cooling power is the highest on the market as well. It's 1.5 milliwatt and the base temperature below 8 millikelvin. But this is just basic model range. We can also offer customized system with more cooling power, less cooling power, lower base temperature. We're very flexible. And the system is pretty modular. For instance, you can easily add or remove the pulse tube. You can buy a system with 1 pulse tube. And later, if you decide you want to put some electronics at 3 Kelvin plate and you want more power, it takes 2 hours to add the second pulse tube. If you want to operate a dilution unit, also get more cooling power, it's very easy to do. Should never happen, but if you need a repair, it's also very easy to remove, for instance, the dilution unit, repair it and put it back. And same with, if the pulse tube is not working, you can easily replace it. Our gas handlings are very compact and very integrated. So the mixture is stored inside of the frame of the gas handling system. So there is no separate mixture tank that takes space, and it's very compact. It also has a microprocessor inside, so it doesn't require any laptop or external connection to operate. From 4 Kelvin down, you can just press a start button, and the system will cool to base temperature and will stay at base temperature. It also has built-in safeties, so say your circulation circuit got plugged, it will detect that the pressure is rising and open the valves and recover the mixture to save expensive helium-3. Also has a battery, so it will detect that there is no external power loss, and it will also open the valves. It cannot run the pump, the small battery, but it can open the valves and keep the system running so the helium can escape if there is a power loss. And we have an option of maintenance-free pumps, which, like magnetic levitated turbos and this multi-stage roots clock lamps, which don't require any maintenance at all and can run for years continuously without any service. So this is one of the unique features of our fridge. It's called the lifting table. So the idea is that our cans and shields are stacked inside like a Russian doll. There is some brackets. So the idea is when you want to close the cryostat, you actually lift the whole fridge up. You put the cans under it, and then you lower the cryostat into the cans. Then you tighten the screws, lift it a little bit, remove those brackets, continue to the next can. So one person can close it in 15, 20 minutes, and it doesn't matter if you have a 150 kilo magnet inside your IVC, or if you have, new metal shielding installed. It's mounted in this, stacked on the little trolley on the wheels. You put it on the fridge, you lower the fridge into it, and you close it. Okay. So this is the part that most people in quantum computing are interested in, is wiring. Our system has up to 6 line-of-sight ports of 120 millimeters. And in these ports, we put these wiring inserts, which we call semi-probes. So this is the structure you can put on the table, assemble, put your semi-rigids, put your cryo-amplifiers, circulators, directional couplers, whatever you need. You load it into the cryostat. You tighten 6 screws on top of the cryostat and 1 screw on each plate, and it's fixed. So it takes 5 minutes to install it. It goes all the way to the mixing chamber. So from there you can, put filters, or you can put wire into your quantum chip, whatever you want. Also, because we make pretty much everything in-house, we manufacture in-house, we make wiring ourselves, we are very flexible. So we can, we discuss with the customer what he wants, we make a diagram of the wiring he wants, components he wants to put, make a 3D CAD, get an approval, machine all the parts, machine the brackets, machine terminalizations, everything, and put it on the fridge. Oh, this is, I think, is a nice example of a system we delivered last year to Barcelona Supercomputing Center, together with a Spanish company, Kilimanjaro. So we supply 2 of our biggest cryostats, and the wiring comes from Delft Circuits, another company in Delft, and the quantum chip is from Quantware, I believe. Yes. And it's now, and as you can see, it's different colors because apparently it's the colors of the football club of Barcelona. So the other options is the cold insertable probe for fast sample exchange. It's not very popular in quantum community, but for instance, we just heard the talk about traveling wave parametric amplifiers, which they use one of our cold top loader probes for fast sample test and prototyping. We of course make magnets up to 14 Tesla single axis or 12 Tesla and vector magnet with different bore diameters up to 110, 120 millimeter. You can, tune it to your sample size, to the old finger size. We have optical access, all axial and radial, also option for the optical fibers for people who need to build the optics or NV centers. Because our fridge is heavy and low vibrations, we work quite a lot with Attacube to develop these like AFM, CFM microscopes. Mostly it is mounted on the top loader probe, and they measured an RMS noise of about 1.5 nanometer at the base temperature, about 30, 40 millikelvin, while doing the scans. As another option, if base temperature of 10 millikelvin, 8 millikelvin is not enough, we also offer nuclear demagnetization stages. It's not a continuous, it's a single shot process, but you can actually go below 1 millikelvin for hours if you need it. So in this case, for instance, this is the system we developed for Leiden University. It was under 1 millikelvin for 17 hours, and then the technician came and bumped into the cryostat. It warmed up. Otherwise, it would have stayed even longer. Another system that we made and already sold 3 of is a Model XXL. So this cryostat has a mixing chamber of 1, weighs 2.5 tons, and it takes around a week to cool down, but it still reaches a base temperature of 5 millikelvin and a cooling power of 3 milliwatt at 120 millikelvin. S11 120 millimeter line of sight ports. So with high density wiring, you can put literally thousands of lines in it if you need it. And because it's using the same lifting table, and because it's using the same lifting table, still it can be opened and closed by one person. But you can do it. Okay, this is the last slide. And for something completely different, we're actually now developing a system which is small. This is a tabletop cryostat. There is a footprint of it, the design of it there on the bottom left corner. So the idea is they can only open and close the top part, because about 30 centimeter sample space. Very small, very easy to operate, very cheap. This is the first prototype we built. It's a bit underperforming right now, but I think next year that will be our standard product that we also offer. Okay, thank you.
Thank you very much for your presentation. Nice presentation. Some comments and questions, please. I have some technical questions for you. To you. For example, the superconducting qubit requires the cryostat magnetic field-free cryostat.
Yes.
So, are you investigating the material from the point of view magnetic or non-magnetic in order to optimize?
Yes, for sure. So
because, for example, brass is magnetic. So this is very important.
We take care of that. For instance, typically if you do gold plating on copper, you use a nickel as a buffer layer. We don't do that because.
Yes.
For instance, depending on we use standardly copper-nickel wires, semi-rigid, but some people obviously also don't want copper-nickel, so then we use beryllium copper. And same for, we use brass also a lot as a standard material, but if that's a problem, we can use phosphor bronze, which is non-magnetic. So we do provide solutions for people that want absolutely no magnetic materials. And we provide magnetic shield, we can offer magnetic shielding around the whole cryostat, around your sample, like quantum chip, superconducting or mu metal, cryoperm shielding. So we can provide all that.
Thank you very much for the reply. Another comments and questions? Thank you very much again. Thank you very much again.